Hey team, here we go. I'm going through these fast. Even though number 30 terrifies me, I don't like variables in the denominator. Did I mention? Okay, but we're going to do it. Here we go. I see right now that 7 goes into 14. Do y'all see that? I hope you see that. So I'm going to multiply this top equation times 2 and this bottom equation times nothing because it already doesn't need anything because then it'll be the same. Okay, so I will end up then 2 times 6 over x is 12 over x minus 14 over y. You'll see that? Equals 16. Now, the signs are the same, okay? And so I've got 15 over x minus 12 over x, okay? Which does equal 3 over x. 14 over y minus 14 over y equals nothing. And 21 minus 16 equals 5. The other day in class I told y'all that I don't like this at all, and so I actually do this really complicated thing where I then write 3 equals 5x. Not complicated, but longer because it makes me feel safe and warm and fuzzy. And then we divide by 5, and now we have 3/5 equals x. Let me check. I'm right. Yay! Okay, now, y'all can, if you want to, find a common factor for 6 and 15. It's just going to be 30. Okay, so you could just resolve the equation, multiply this top one by 5 and this one by 2, and you would end up with 30 over x and 30 over x. But y'all have a fraction problem, so I'm about to show you how to deal with this by plugging in 3/5 for x into this top equation. So now we have 6 over 3/5 minus 7 over y equals 8. Okay? How do you divide by a fraction? Well, the mathematically correct term for that is, so you're dividing 6 by a fraction. Do you see that? 6 divided by 3/5. The mathematically correct term for that is to divide by a fraction, you multiply by its reciprocal. Hallie taught us what her 6th grade math teacher taught us the other day, and she taught us to say, keep the first fraction, change the operation, flip the second fraction. So 6 divided by 3 over 5 could be written 6 over 1 divided by, that's an ugly division sign, divided by 3/5, okay? And she said her math teacher told her to say 6 over 1, keep the first one, change the operation, and then flip the second one. Guys, all we're doing is saying when you divide by a fraction, you multiply by its reciprocal. And of course, a reciprocal is just just turn it over. Boop, upside down. Okay? So 6 times 5 is 30. 1 times 3 is 3. 30 over 3 is secretly just what? 10. So now I have 10 minus 7y equals 8. So now I have -7, 7 over y. -7 over y equals -2. Y'all know I don't feel comfortable with this, so I say -7 equals -2y. And then I say y equals 7/2. I'm going to look at my answer key. Ha! Victory, victory, victory. Okay. So here's our answer. And it really is, we could just write it like this. 3/5, 7/2. Okay. So the moral of that story is that most of your mistakes are going to have happened in the math. The system wasn't hard, but the math lended itself to many careless mistakes. So hopefully you didn't make any. Okay. Now here we go. Okay. This is number 36. This is down there in the section that says determine whether the equations in the system are independent, dependent, or inconsistent. Okay? Independent, dependent, or inconsistent. Okay, so to do that, you're probably going to need to know what those mean, right? I know that hurts y'all's feelings. It's not supposed to be vocabulary class. It's supposed to be math class, but oh well. It's hard to be y'all. Okay, so look back on the bottom of page 115, okay? And it says inconsistent equations are used for any equations that have no common solutions. If the two equations in the system have the same graph, then they are called dependent equations. Such systems have an infinite number of solutions. Linear equations whose graphs intersect at just one point are called independent equations. And then you can look at the top of 116 and see our three possibilities. Okay guys, I'm just going to be real honest with y'all. You can just solve this. If you get a solution, you get to call it independent, right? They didn't ask you for solutions, they does it have one. If it has one, it's independent. But you could also check to see if they are in fact either the same equation or a different equation with the same slope. Right? If they're the same equation, that would make them dependent, if they end up with the same graph. Or the same equation, with an equation with the same slope but a different y-intercept would mean that they are not, that would mean they are inconsistent parallel lines, right? So instead of solving this system, I'm going to just go like this. I'm going to put it in slope y-intercept form because that makes me happy. So I'm going to say 56y equals negative 24x plus 72. Okay? And then I'm going to say 15x. Oop, didn't mean to do that. Sorry. I'm going to solve this first. Y equals negative 24 over 56x plus 72 over 56. I recognize neither one of those is reduced. I don't care right now. Okay? I'm going to leave it alone for right now. Now I'm going to take the second one over here and also put it into slope y-intercept, and it's going to say negative 35y equals negative 15x plus 54. So y equals 15 35ths x. I'm just going to go ahead and get rid of the negatives because it's negative 15 divided by negative 34, right? And then negative 54 35ths, okay? So now, y equals 15 over 35x, and y equals negative 24 over 56. Hey guys, guess what? They're not parallel, nor are they dependent. Why? Because they don't have the same slope. It doesn't, you could reduce these. Let's just do that. 15 over 35 reduced would be, that divided by 5 is 3. 35 divided by 7 is 3/7. So that slope of this one is 3/7. This one over here, divide them both by 2, and you get 12 over 28. Do it again, and you get 6 over 14. Do it again, and you get negative 3/7. Gosh, those slopes are awfully close. But they're not even really close at all, because why? Those lines are, one has a negative slope and one has a positive slope. So I didn't even need to do all that reducing. Why? Because I looked at them and saw that one has a positive and one has a negative. Okay? And really, I probably could have done that before I even started any of this by looking here and seeing positive, 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 negative. No way that has the same graph, right? If I had seen a negative somewhere else up here and a positive down here, I wouldn't have known if those two might have canceled themselves out, okay? But looking right now, I see that we have different signs in these equations. We're probably not going to have the same slope. And then I confirmed it, that it wasn't some weird thing going on, and got to slope-intercept form and saw a positive slope here and a negative slope here, meaning they must be independent, because if they were dependent or inconsistent, being parallel, then that would mean they had the same slope. Either the same slope with a different y-intercept, making them parallel, or the same slope with the same y-intercept, making them the same graph, making them dependent equations. Okay, friends, whew, Almost 30 minutes worth of me talking. Y'all shouldn't have to sit through that on any day other than a Tuesday or Thursday. I am so sorry. I'm really not. I hope this was helpful for you. If it wasn't, then I apologize, but I'm just doing what I think would be most helpful for y'all. I hope that your afternoon or morning, whatever day of the week it is, whatever time you're watching this, goes great, and I will see you Tuesday at 9:30 sharp. Thank you, friends. Bye.